Greetings, my dear listeners. Today we begin a great journey, not through space but through time, not along the roads of the earth, but across the boundless horizons of the universe and into its possible future. We shall ask ourselves perhaps the grandest and most unsettling of all questions. What awaits our universe at the end of its story? Will it die a cold death? Will it be torn apart? Will it collapse back into a blazing fireball? Or will the future turn out to be even more astonishing than we dare imagine? This is a question that places us in a unique position. We, small beings living on a tiny planet, dare to contemplate the fate of the entire cosmos. Is that not wondrous? Is it not touching to realize that atoms, assembled into human bodies, can reflect upon the destiny of all atoms combined? In this first chapter of our journey, we will set the direction. We will try to understand why the theme of the end of the universe touches humanity so deeply. We will recall how ancient peoples imagined the fate of the world. We will see what modern science says. And most importantly, we will ask the philosophical questions. Why do we even need to know about the end of the universe? What does such knowledge change in our lives here and now? Let us begin by imagining how people saw the cosmos thousands of years ago. The night sky appeared eternal and unmoving. The stars rose and set, but they were the same stars as in the days of our ancestors. To ancient humans, the sky was a symbol of eternity. And yet, in many myths, the world did come to an end. The Norse spoke of Ragnarok, the great battle after which the world would be renewed. The Indians described the cycles of yugas, where the world is destroyed and recreated again and again. In the Bible, But what does knowledge of the end of the universe give us? It may seem that it changes nothing. These events lie so far in the future that we will never see them. But therein lies the power of such knowledge. It expands our consciousness. It carries us beyond the everyday. When we think in billions of years about the fate of stars and galaxies, we see our lives from a different scale. We realize their fragility, but also their value. Awareness of the end of the universe makes every one of our days meaningful. The physics of the 20th century revealed that the universe is not eternal. It has a beginning, the Big Bang. And if it has a beginning, it must also have a future. Today, scientists consider several scenarios. One is heat death, the slow fading into cold silence. Another is the Big Rip, accelerated expansion tearing everything apart. A third is the Big Crunch, collapse back into a fireball. There are also bolder ideas, multiverses, quantum fluctuations, new worlds. Each scenario is not only a scientific hypothesis, but let us ask ourselves a few questions. If the universe is finite, does that mean life has no meaning? If the cosmos will die, does that render our deeds worthless? Or, on the contrary, does finitude give value to every moment? After all, is this not true in our own lives? We know they are finite, and precisely because of this, every day matters. In this series of chapters, we will seek answers not only in formulas, but in the stories of people. We will talk about Lord Kelvin and his idea of heat death, about Vera Rubin and her discovery of dark matter, about Robert Caldwell and his hypothesis of the Big Rip. We will recall myths about the end of the world and see how they resonate with modern theories. We will turn to philosophers and writers to understand how they perceived the end, and all this not for idle curiosity, but to better understand ourselves. Philosophical pauses will accompany us constantly. I will invite you to stop and think, what does this theory mean for me personally? How do I feel about the idea of the end? Does it change my outlook on life? Because in the end, when we discuss the fate of the cosmos, we are really discussing our own fate. We are part of this story, and we must not forget that. So, my dear listeners, our journey begins. We set out to explore the destiny of the universe. We will move from myths to science, from fear to inspiration. Perhaps at the end of this path we will not find a final answer, but we will surely discover how to look at the stars and see in them not only distant light, but also the reflection of our own destiny. And let this thought be our starting point. For the end of the universe is not only a tragedy, it is also an invitation to life. To live in such a way that the history of ideas about the end of the world and the cosmos. Greetings once again, my dear listeners. In our first chapter, we only outlined the direction of our journey and asked the great question: what awaits the universe in the future? Now it is time to look back and see how humanity even came to such a thought. The idea of the end of the world is not new. It has accompanied us since ancient times, traveling the long road from myths to rigorous physical equations. Let us begin with ancient myths. In Norse tradition, there was Ragnarok, the day of the great battle of gods and giants. In that catastrophe, the world sinks into fire, rivers of blood flow across the land, and the sun is extinguished. But after this destruction, a new world is born, green, blooming, full of life. The end here is a beginning. In India, there was the concept of yugas. Each epoch lasts millions of years and ends in destruction, but out of it arises new creation. This is the eternal breath of. All these myths share a single thought. The end of the world is needed in order to renew it. It is not only a catastrophe, it is also a hope. And is this not very similar to how we experience our own lives? We fear the end, but we believe that in it there may lie hidden meaning. Gradually, humanity began to think of the cosmos not only through myth, but also through philosophy. Already in antiquity, extraordinary ideas were voiced. The Stoics, for example, spoke of the great conflagration, the periodic destruction of the universe in fire, after which everything begins anew. For them, this was the natural rhythm of nature. The Epicureans, meanwhile, believed that worlds were infinite in number, and each had its cycle of birth and death. Here we see an important shift. Humans beg. In the Middle Ages, the theme of the end of the universe was tightly bound to religion. Christian Europe lived in expectation of the apocalypse, the end of time, and the last judgment. Generations believed that the end was near. And yet, even then, there were thinkers who tried to look further. Roger Bacon, for instance, mused that the universe might be far larger than humans assumed, and that its destiny was a mystery hidden from us. In such words, we already hear the transition from a purely religious. Then came the modern era. Science began to reshape the human vision of the world. Nicholas Copernicus showed that the Earth is not the center of the universe. Galileo, with his telescope, saw the moons of Jupiter and the phases of Venus. Giordano Bruno dared to speak of an infinite cosmos filled with countless worlds, and for this he paid with his life. And here a new question was born. If worlds are infinite in number, does that mean each of them has an end? And if so, is our world also mortal? In the 19th century, humanity first encountered a scientific idea of the end of the universe. Lord Kelvin and Rudolf Clausius formulated the second law of thermodynamics. They showed that entropy always increases. This means that energy will eventually distribute evenly, and processes will cease. This is the so-called heat death. For people of the 19th century, this discovery was shocking. An age of progress, an age that believed in infinite growth, suddenly heard, an end is inevitable. Philosophers of that time responded to this news in their own way. Arthur Schopenhauer wrote of the world as will, always striving and suffering, and therefore incapable of eternity. Friedrich Nietzsche spoke of eternal recurrence, challenging everyone. Are you prepared to live life in such a way that you would want to repeat it infinitely many times? These words were not accidental. They reflected the atmosphere of a century in which humans first began to contemplate not only their own mortality, but the 20th century made the next step. In 1929, Edwin Hubble discovered the expansion of the universe. Galaxies are receding from one another, and the farther they are, the faster they move away. This meant that the cosmos is not eternal. It evolves. In 1965, Arno Penzias and Robert Wilson discovered the cosmic microwave background, the afterglow of the Big Bang. The theory of the universe's beginning became fact, and if it has a beginning, then it must also have a future. The question of the end now step. Scientists argued, will the universe collapse back in a big crunch, or will it expand forever and freeze in a heat death? Later, in the late 20th century, the discovery of accelerated expansion added yet another scenario, the Big Rip. Thus, ideas that were once myths became strict models based on observation and mathematics. Let us pause and ask a rhetorical question. Why do we think so much about the end? Why does this thought haunt us? Perhaps because it reminds us of our own mortality, that everything has a limit. But is this not precisely the source of meaning? For if all things are finite, then every moment becomes priceless. And so, dear listeners, the history of ideas about the end of the universe is the history of humanity itself. From myths to formulas, from divine prophecies to physical equations, every step on this path reflected not only our knowledge of the cosmos, but also our understanding of ourselves. In the next chapter, we will turn to the 20th century as a whole, the era when cosmology truly became a science. We will see how the discoveries of Einstein, Friedman, Hubble, and others forever changed our vision of the 20th century cosmos, the birth of a new vision. Greetings again, my dear listeners. In the previous chapter, we traced how humanity, step by step, approached the thought of the end of the world. From myths of Ragnarok and the apocalypse, to the strict formulations of the second law of thermodynamics. Today, it is time to enter the 20th century, the century of scientific revolutions, when cosmology transformed from philosophical speculation into a rigorous science. It was in the 20th century that we first saw the universe as it truly is, alive, dynamic, Eve. We must begin, of course, with Albert Einstein. In 1915, he created the general theory of relativity, one of the greatest achievements of human thought. This theory overturned our understanding of gravity. It was no longer a force in the usual sense, but the curvature of space and time. And immediately the question arose, What would happen if these equations were applied to the entire universe? Einstein attempted this. His equations showed that the cosmos could not be static. It had to either expand or At the same time, in the Soviet Union, a young mathematician named Alexander Friedmann, relying on Einstein's equations, developed models of a dynamic universe. He showed that the cosmos could expand or contract, and that this was a natural consequence of general relativity. But his contemporaries did not take him seriously. Even Einstein at first rejected his ideas. Only decades later did it become clear Friedmann was right. Then came 1929. Edwin Hubble, working at the Mount Wilson Observatory, made a discovery that changed everything. By studying the spectra of distant galaxies, he noticed that they were moving away from us. Moreover, the farther a galaxy was, the faster it receded. This was the first direct evidence that the universe is expanding. The picture of an eternal and unchanging cosmos collapsed instantly. Now it was clear. The universe has a history. It had a past, and it will have a future. Think about what a shock this was. For thousands of years, people saw eternity in the sky. And suddenly it turned out. The cosmos evolves. This meant that if one were to trace time backwards, we would arrive at a moment of beginning. Thus, the idea of the Big Bang was born, and at the same time, the idea of a possible end. But discoveries did not stop there. In 1965, Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background radiation, a faint echo of the hot beginning of the universe. They were trying to tune their antenna and could not get rid of a persistent noise. They even cleaned it of pigeon droppings, but the noise remained. Soon it became clear. This was not interference. It was ancient light coming from the dawn of time itself. This discovery was decisive proof of the Big Bang theory. The second half of the 20th century brought new mysteries. Scientists measured the rate of expansion, observed quasars and pulsars, and studied galaxy rotation. They found that the visible mass was insufficient to hold galaxies together. Thus, the idea of dark matter arose. Later, it became clear that the expansion of the universe was accelerating. The hypothesis of dark energy was born. The picture was becoming ever more complex, and the questions multiplied. Philosophically, the 20th century was a time of shattered illusions. We could no longer think of the universe as eternal and unchanging. It turned out to be alive, like everything around us. It is born, develops, and will likely die. For some, this became a source of fear. For others, a source of inspiration. For if the cosmos is alive, then we are part of it. We participate in its grand story. Let us ask ourselves a rhetorical question. What does it mean to live in an era when we first learned that the universe expands? We are the first generation to know that the cosmos is not eternal. We are witnesses to a discovery that changed not only science, but also philosophy. And does that not make our time unique? The stories of 20th century scientists are tales of courage and curiosity. Friedmann, who dared to oppose Einstein himself. Hubble, who, with his telescope, showed that we live in one galaxy among billions of others. Penzias and Wilson, who accidentally confirmed the theory of the Big Bang. All of them were people brave enough to look beyond the familiar. So, my dear listeners, The 20th century gave us a new vision of the cosmos. We learned that it expands, that it had a beginning, that its fate depends on mysterious forces, dark matter and dark energy. In the next chapter, we will look more closely at these forces. We will see how they shape the future of the universe and why, without understanding them, we cannot predict its end. The dark forces of the cosmos, matter and energy beyond the visible. Greetings once again, my dear listeners. In the previous chapter, we spoke of how the 20th century gave us a new vision of the cosmos, alive and ever-changing. But with these discoveries came new mysteries, and perhaps the greatest of them are tied to that which we cannot see. Today, we will talk about dark matter and dark energy, the two greatest enigmas of modern cosmology, without which it is impossible to understand the future of the universe. Let us begin with dark matter. In the 1930s, Swiss astronomer Fritz Zwicky observed clusters of galaxies. He noticed something strange. Galaxies within the clusters moved too quickly. If there were only the visible mass, stars, gas, and dust, they should have flown apart, but they did not. This meant that there was something invisible holding them together. Zwicky called it dark matter. His idea was not taken seriously for a long time, but science knows how to wait for its hour. In the 1970s, American astronomer Vera Rubin carried out detailed studies of galactic rotation. She found that stars on the outskirts of galaxies moved just as fast as those near the center. This was impossible if only visible matter were present. It meant that every galaxy was surrounded by an unseen halo of dark matter. Her work changed cosmology forever. Today we know dark matter makes up about 5 times more than all ordinary matter, the stars, planets, and even ourselves. But what is this matter? We cannot see it. It does not emit or absorb light. It barely interacts with normal matter. Scientists suggest it may consist of new particles, WIMPs, axions, or something else entirely unknown. Researchers search for it in underground laboratories, particle accelerators, and through cosmic observations. Yet so far it remains elusive. There is something almost mystical about it. We feel its presence but cannot touch it. And now, dark energy. Its discovery shook the scientific world. In the late 1990s, 2 teams of astronomers studied distant supernovae, stellar explosions used as standard candles to measure cosmic distances. They expected that the universe's expansion would be slowing down under gravity, but instead, they found the opposite. It was accelerating. This discovery earned the Nobel Prize and forced scientists to introduce a new concept, dark energy. What is it? We do not know. It may be a property of space itself, as Einstein hinted when he introduced his cosmological constant. It may be some kind of field unknown to science. But one thing is certain. Dark energy makes up about 70% of the universe's content. It is the main force shaping its destiny. Its behavior will determine whether the cosmos dies a heat death, is torn apart in a big rip, or meets some other fate. Let us pause and reflect. 95% of the universe is darkness that we do not understand. Only 5% is the matter of stars, planets, and ourselves. Does this not put us in our place? We pride ourselves on our knowledge, but in truth, we have only just begun to glimpse the picture. perhaps the most important discoveries are still ahead. The stories of Zwicky and Rubin are not only about science, but about people. Zwicky, with his difficult character, was often considered eccentric. His ideas were dismissed, but he was right. Vera Rubin, a woman in the male-dominated world of astronomy, faced bias, but her persistence changed science. These stories remind us that behind every discovery lie human struggles, courage, and persistence. Philosophically, dark matter and dark energy teach us humility. We like to think the world is comprehensible, but it turns out we see only a small part of it. The universe remains mysterious, and in that lies inspiration, for it is ignorance that makes the journey worthwhile. If we knew everything already, there would be no reason to search. Let us ask a rhetorical question. What if everything we call dark is simply a reflection of our own ignorance, the shadow of our limits? Perhaps the universe is transparent and simple, and complexity is only the mirror of what we do not yet know. So, my dear listeners, we have met the two greatest mysteries of the cosmos. Dark matter holds galaxies together. Dark energy pushes them apart. They are the keys to the universe's future. In the next chapter, we will explore the first scenario of the end: heat death, when energy disperses and the cosmos sinks into cold silence. Heat, death of the universe, the cold silence of the future. Greetings once again, my dear listeners. In the previous chapter, we spoke of the great enigmas of the cosmos, dark matter and dark energy. But now it is time to turn to one of the oldest and most rigorous scenarios for the end of the universe. This is the hypothesis of heat death, born in the 19th century and still holding power today. It terrifies with its silence and emptiness. Unlike fiery catastrophes, it has no explosions, no flames, no cries. There is only the slow fading of all that exists. To understand this scenario, we must recall the law of increasing entropy. In everyday life, we encounter it constantly. A broken glass never reassembles itself. Melted ice does not spontaneously become cubes again. Entropy is the measure of disorder, and it always increases. Apply this to the universe as a whole, and we see a picture where, over time, energy is evenly distributed and processes cease. This is heat death. In the 19th century, Lord Kelvin was the first to speak of this. For his contemporaries, it was a shock. The era believed in progress, in endless growth, in a future always brighter than the present. And here science declared, one day everything will fade. Ahead lies not eternal advancement, but equilibrium where nothing further occurs. This thought seemed almost blasphemous, but it was also the strength of science, the courage to look truth in the eye. What would heat death look like? Let us imagine. Millions and billions of years pass. Stars burn out. Last of all, red dwarfs, living trillions of years, exhaust their fuel. White dwarfs cool and turn into cold black spheres. Neutron stars lose their heat. Black holes gradually evaporate via Hawking radiation. Ever more slowly, but inexorably, the universe fades. At last comes the Black Era, an age of darkness and silence. Philosophically, this picture horrifies. Unlike dramatic apocalypses, there is no spectacle here, no final act. only the slow departure of everything. The cosmos does not die in a flash. It dims like a candle left in the wind. And perhaps that is why this scenario frightens us more than others, for it robs the universe even of tragedy's final act. But let us pause and ask, is this truly the end, or is it a transition? Some physicists propose that quantum fluctuations may occur in the void, that even in a dead cosmos, new seeds might form. Perhaps heat death is not an end, but preparation for a new beginning. The history of science preserves human dramas as well. Ludwig Boltzmann, one of those who developed the concept of entropy, saw in it a strict law of nature. For him, the growth of entropy was not a verdict, but an expression of deep cosmic order. His ideas were long rejected, and he faced misunderstanding, ultimately ending his life tragically. Yet today, his name stands among the greatest scientists, and his equation adorns his tombstone. This reminds us, truth is often born through struggle. Philosophers, too, reflected on heat death. Some saw in it the meaninglessness of existence. Others, on the contrary, found in it a source of meaning. For if time is limited, then every moment is precious. If even stars are not eternal, does that diminish their beauty? No, it sharpens it. We cherish a flower because it wilts. We cherish life because it ends. Perhaps we should cherish the universe itself precisely because it is not eternal. Consider this. We live in the age of light. We see the stars. We are warmed by the sun. We breathe air on a planet embraced by starlight. All this is temporary, but therein lies the beauty. We are witnesses of the cosmos in its prime, and knowledge of heat death should not frighten us but inspire us. It reminds us, time is valuable precisely because it is finite. So, my dear listeners, the scenario of heat death paints a cold future where the universe fades into silence. But along with this, it gives us a lesson. It teaches us to value the present. In the next chapter, we will explore another scenario, the opposite one. It is the Big Rip, a violent and swift demise, in which the very fabric of space tears apart. The Big Rip, a universe tearing itself apart. Greetings once again, my dear listeners. In the previous chapter, we spoke of the slow and cold end, the heat death of the universe. But there is a scenario of an entirely opposite nature. In it, the end comes not in silence, but in a storm, not in fading, but in a catastrophic rupture. This is the scenario known as the Big Rip. It was proposed only recently, but it instantly captured the imagination of scientists and philosophers alike. The history of this hypothesis begins in the late 20th century, when astronomers discovered the accelerated expansion of the universe. We already know galaxies are not only moving apart, but doing so faster and faster. To explain this, scientists introduced the concept of dark energy. It pervades space and pushes it outward. But what if this force keeps growing without limit? What if its pressure becomes stronger and stronger? Then the moment will come when no gravity can hold structures together. Let us try to picture this step by step. First, galaxies drift apart. The light of distant worlds fades, and the night sky grows emptier. Then the expansion rips apart galaxies themselves. Stars can no longer remain bound. Next, star systems dissolve, planets drift away. Yet even that is not the final stage. Dark energy tears apart atoms, even elementary particles. In the very end, the fabric of space-time itself is ripped. The end of the world becomes a cosmic wreck, grand and terrifying. This scenario was mathematically described by Robert Caldwell and his colleagues in the early 2000s. They showed that if dark energy has what is called a phantom equation of state, then its pressure grows toward infinity. In that case, the end might come not in trillions of years, but far sooner, perhaps in just tens of billions. On the cosmic scale, that is almost the blink of an eye. Philosophically, the Big Rip is mesmerizing. It promises not emptiness, but storm. Not slow fading, but a furious finale. In this, there is something mythological. Recall ancient prophecies. The end of the world was often imagined as catastrophe, as fire, as ruin. The Big Rip is the scientific version of those old visions. But here, instead of gods, we have equations, and instead of seers, we have physicists. But let us ask, which is more frightening? A slow fade or a sudden catastrophe? Which is closer to us as beings accustomed to drama? For some, heat death is more terrifying because it leaves nothing but endless stillness. For others, the Big Rip is worse because it destroys everything in fire and pain. Yet both scenarios speak of the same truth: finitude. And finitude always unsettles us, no matter its form. Imagine what it would be like for hypothetical observers. At first, they would notice the stars disappearing from their skies. Then their own galaxy would lose its structure, stars drifting apart. Next, planets and atoms themselves would disintegrate, and in the final instant, even the space in which they existed would vanish. This picture is terrifying, yet there is also strange beauty in it. The universe departs not in silence, but in a furious burst of force, a finale worthy of a tragedy. The story of its proposal is also worth noting. Robert Caldwell and his colleagues knew their hypothesis might never be confirmed, but they dared to put it forward. And that is the essence of science, the courage to ask questions, even frightening ones. To draw conclusions, even if they disturb. In this way, science is like art. It paints pictures that make us think. Philosophers, too, find reason to reflect in the Big Rip. If the world dies in catastrophe, does that mean life is meaningless? Or does catastrophe itself make each moment meaningful? If the end may be closer, even billions of years away, does that not make our lives more precious right now? And here we return to the central thought. Scenarios of the end are not only about the future, they are also mirrors of our present. We will never witness the Big Rip with our own eyes, but the very idea of it teaches us to value our time. We live in an age of balance, when the cosmos is filled with light. We are children of the universe in its prime, and this knowledge makes our existence unique. So, my dear listeners, the scenario of the Big Rip is a vision of a violent end where the fabric of space itself tears apart. In the next chapter, we will examine another possibility, the Big Crunch, in which the universe does not rip but collapses back, returning to where it began. The Big Crunch, a return to the beginning. Greetings once again, my dear listeners. We have already examined two scenarios of the end, the slow fading into silence, the heat death, and the violent cataclysm, the Big Rip. But there is yet another option, just as dramatic and, in some ways, even poetic. This is the scenario of the Big Crunch. In it, the universe does not vanish into cold emptiness, nor does it tear itself apart. Instead, it contracts back upon itself, returning to the state from which it began. Here, the end becomes the mirror of T. This idea was born in the early decades of the 20th century. After Albert Einstein formulated the general theory of relativity, it became clear. The universe could not remain static. It must either expand or contract. In the 1920s, Alexander Friedmann developed equations describing a dynamic universe. He showed that if there were enough matter in the cosmos, gravity would eventually halt expansion and trigger collapse. In such a case, the cosmos would not expand forever but would return, falling inward. Later, American physicist Richard Tolman expanded on these ideas. He proposed the model of a cyclic universe, expansion followed by contraction, Big Bang transforming into Big Crunch, and then everything beginning anew. For Tolman, this was not only mathematics but also philosophy. The cosmos in his model resembled breathing, inhalation and exhalation, life and death, eternal rhythm. What might this look like in practice? Imagine billions of years of expansion. But slowly, gravity begins to slow it down. The speed at which galaxies move apart decreases. At first, this is barely perceptible, but then galaxies begin to converge. The night sky grows brighter as distant worlds draw near again. Galaxies collide, merge, and new stars are born. The cosmos seethes with events. Yet this activity is a prelude to the end. In the finale, everything contracts into a fiery mass, into a singularity Philosophically, this scenario is especially captivating. It recalls ancient myths of eternal return. The Indian cycles of yugas, the Norse Ragnarok, the Platonic ideas of cyclical time all find scientific reflection here. Humanity has always struggled to accept a final end. It is easier for us to think of repetition, of new birth. And the Big Crunch provides just such an opportunity. The death of the universe transforms into the beginning of a new cycle. In the mid-20th century, this scenario seemed quite plausible. Scientists did not yet know the density of matter in the universe. If it were slightly above the critical value, gravity would stop expansion and trigger contraction. Many astronomers seriously considered this outcome. But in the late 20th century, the discovery of accelerated expansion changed the picture. Dark energy proved stronger than gravity. Today, most models predict eternal expansion. Yet that does not mean the idea of the Big Crunch. Think of the poetic power contained in this scenario. The universe dies, but its death is simultaneously a birth. It returns to the beginning to trace the path anew. It reminds us of Nietzsche and his idea of eternal recurrence. Could you live your life in such a way that you would want to repeat it endlessly? For philosophers, this is a challenge. For poets, a source of inspiration. For scientists, a bold hypothesis. The people behind this idea also left important legacies. Alexander Friedman, whose equations predicted a dynamic universe, died young and never saw the confirmation of his ideas. Richard Tolman, the theorist who connected physics with philosophy, left a heritage that endures even today. Their stories remind us that science is not only formulas, but also a worldview and the courage to think about the grandest questions. Let us ask a rhetorical question. If the universe is truly cyclical, what does that mean for us? Does it make life more meaningful, or does it strip it of uniqueness, turning it into endless repetition? Perhaps the truth lies in between. Even if cycles repeat, we still live one single unique life, and it is this uniqueness that makes it precious. So, my dear listeners, the scenario of the Big Crunch is a grand vision where the end becomes a beginning. It is not death in emptiness, but death in fire, followed by rebirth. Today, science leans toward other models, but the thought of cyclicity remains enchanting. In the next chapter, we will turn to even bolder ideas, quantum fluctuations, multiverses, and other exotic concepts that suggest the future of the cosmos may be stranger than we can imagine. Exotic scenarios, quantum fluctuations, and the multiverse. Greetings once again, my dear listeners. We have already examined 3 classic scenarios for the end of the universe: heat death, the Big Rip, and the Big Crunch. Each has its arguments and weaknesses. But cosmology does not limit itself to these options. Scientists and philosophers also propose more exotic ideas, which may sound like science fiction, yet are rooted in serious theories. Today we shall discuss them. We will look into that boundary where science meets imagination. Let us begin with quantum fluctuations. In the quantum world, emptiness is never truly empty. Even if all matter and energy were removed, space itself would still flicker. Particles and antiparticles emerge and vanish like waves on the ocean's surface. This phenomenon is well confirmed by experiments. But if quantum fluctuations are real, they may have cosmological consequences. They may, for example, generate new bubbles of universes, born right out of space itself. From this idea arose the hypothesis of the multiverse. According to some versions of inflationary theory, our Big Bang was not unique. Space expands, and within it new regions form where universes are born. Each may have its own physical laws, constants, and history. We live in only one, but there may be infinitely many. And this means that the end of our universe does not necessarily mean the end of all things. Somewhere else, new worlds may be born even if ours perishes. Another exotic hypothesis is vacuum decay. Modern physics suggests that our space may be in a metastable state. It is like a ball stuck in a shallow valley, with a deeper valley nearby. If a quantum fluctuation pushes the ball into the deeper valley, the vacuum changes. This event would instantly alter the laws of physics across that entire region of space. This is the so-called false vacuum and true vacuum. If our world is unstable, one day such a transition may occur, and with it the universe as Big W. It sounds frightening. Yet philosophically it reminds us of the fragility of all things. We are used to thinking of the laws of physics as eternal. But what if they are temporary states? What if the very foundations of reality may one day shift? This does not make our lives meaningless. On the contrary, it makes them precious. For we live here and now, in this unique set of laws and conditions. Other exotic ideas come from quantum mechanics and string theory. Some physicists suggest that our universe may be part of a higher dimensional space with branes, giant surfaces that may collide with one another. Our Big Bang may have been the result of such a collision. If so, the end of our universe may also be tied to another cosmic impact. For us, it would be an end, but for the cosmos, merely another cycle. Philosophically, the multiverse and quantum hypotheses evoke mixed feelings. On the one hand, they bring hope. If there are infinitely many worlds, then the death of our universe is not the end of everything. On the other hand, they provoke new questions. What does we mean if there are countless versions of us in other universes? Does this not diminish our uniqueness? Or does it, on the contrary, enhance it? Because this particular version of life is the one we are experiencing. The stories of the scientists who proposed these ideas are also instructive. Alan Guth, one of the creators of inflationary theory, introduced the idea of eternal inflation, in which new universes are born endlessly. André Linde developed this into the concept of chaotic inflation. At first, their ideas seemed absurd, but today they are seriously discussed. This is an example of how science may begin with fantasy and grow into rigorous theory. But let us pause and ask, even if the multiverse exists, what does it change for us? We cannot move to another universe. We cannot see it. We live only here. Perhaps the true value of these hypotheses is in how they expand our imagination. They remind us that reality may be far richer than we think, that beyond our experience may lie the unimaginable. So, my dear listeners, we have explored exotic scenarios, quantum fluctuations, the multiverse, vacuum decay, colliding branes. All of these show that the future of the cosmos may be more astonishing than any myth. In the next chapter, we shall speak of how visions of the end of the universe were reflected in culture, literature, and art. For humankind has always sought to understand the end not only through science, but also through images, symbols, and stories. The end of the universe in culture, literature, and art. Greetings once again, my dear listeners. We have already looked at scientific scenarios for the future of the universe: heat, death, the Big Rip, the Big Crunch, and even exotic hypotheses. But humankind has never limited itself to science alone. Thoughts of the end have always lived in our culture. In myths, legends, books, paintings, and films, humanity has returned to this theme again and again. For the end of the world is not only a physical theory, it is a powerful symbol through which we try to From the earliest times, the end of the world has been a central theme of myth. We have already recalled the Norse Ragnarok, the Indian cycles of the Yugas, and the biblical apocalypse. But let us look deeper. In myths, the end often appears as a cleansing. It is a catastrophe, yes, but one after which a new era arises. Fire and flood sweep away the old order so that a new one may take its place. For ancient humans, this was a way to make sense of the cycles of nature. Winter yields to spring, night to. When humanity began to create literature, the motif of the world's end naturally found its way there. In the Middle Ages, apocalyptic visions filled paintings and manuscripts. Dante Alighieri, in his Divine Comedy, described not only hell and paradise, but also the end of time as the moment of ultimate justice. Artists painted the Last Judgment, a grand spectacle where the entire world gathers before eternity. In these images, one feels both fear and hope, the end as the gateway to another world. In the modern era, as science reshaped our worldview, apocalyptic images took new forms. John Milton in Paradise Lost wrote of fall and redemption. Mary Shelley, author of Frankenstein, in her lesser-known novel, The Last Man, described humanity's destruction by plague. Here the end is no longer cosmic, but earthly. And yet it carries the same thought. Humans fear the end, but cannot stop contemplating it. And then came the 20th century, the century of both discovery and disaster. Wars, the atomic bomb, the Cold War, all gave rise to new apocalyptic visions. Science revealed the vulnerability of our world, and writers mirrored it in their works. H.G. Wells in The Time Machine imagined a distant future where the sun dies and the earth sinks into darkness. Isaac Asimov, in his story The Last Question, posed the problem of heat death and the search for a way out. Ray Bradbury wrote of dying civilizations. Artists and filmmakers also turned to the theme. The surrealists, Salvador Dali, and many science fiction painters created images of catastrophe. Cinema gave us a gallery of worlds ending, from disaster films about asteroids and nuclear war to philosophical meditations on the end of time. For example, Lars von Trier's film Melancholia tells of Earth's collision with another planet. Yet at its core, it is about inner apocalypse, about the human soul confronted with the inevitable. Philosophers of the 20th century reflected as well. Martin Heidegger spoke of being toward death as the essence of human existence. Jean-Paul Sartre wrote of freedom and responsibility in the face of nothingness. These ideas resonated with cosmology. For if the universe is mortal, then death is not only personal, but universal. And so the question of meaning becomes even sharper. Let us ask a rhetorical question. Why does art return to the end again and again? Perhaps because the end is a mirror. Looking into it, we see not the future of the world, but ourselves. We fear the end of the universe because we fear our own deaths. Yet in contemplating it, we seek meaning. We hope there is something beyond the end. It is striking that in the late 20th and early 21st centuries, the theme of apocalypse even became fashionable. Films, books, and games about the end of the world became a genre of their own. Why? Perhaps it is a way to cope with fear. Perhaps a way to prepare. Or perhaps simply a form of art that allows us to feel the sharpness of life. So, my dear listeners, the end of the world has always been part of culture. From myths to movies, from Dante to Bradbury, from icons to Hollywood. The end is an image through which humanity speaks of itself, and therein lies its power. In the next chapter, we will turn to the philosophy of time and meaning. For reflection on the end inevitably leads us to ask, what is time? What is meaning? And how should we live, knowing all things come to an end? The philosophy of time and meaning. Greetings once again, my dear listeners. We have already explored scenarios for the end of the universe and the images of apocalypse in culture. But behind all these theories and stories lies a question without which our journey would be incomplete. What is time? And what does meaning signify in a world where everything is finite? This chapter will be special. It is not only about science, but also about philosophy, about how human thought has tried to grasp the most elusive mystery of all, the mystery. Let us begin with something simple. Time has always seemed obvious. We feel it in every moment. But as soon as we ask, "What is time?" we find it difficult to answer. St. Augustine said, "If no one asks me, I know, but if I wish to explain it to him who asks, I do not know." Time is like air. It is always with us, yet it slips through our fingers. For ancient philosophers, time was tied to the cosmos. Aristotle defined it as the number of motion. Time was what measures change. Without motion, there would be no time. Plato described time as the moving image of eternity, a reflection of the ideal world. The Stoics saw time as part of a cycle, an eternal return. Each of these views gave rise to its own vision of the future. With the rise of science, ideas of time also changed. Isaac Newton considered time absolute. It flowed equally everywhere, regardless of events. But Albert Einstein overturned this idea. In his theory of relativity, time became inseparable from space. It depends on speed and gravity. Time near a black hole passes differently than on Earth. This means that time is not a universal stream, but part of the fabric of the cosmos. And if space can expand or contract, time too must follow. But the philosophy of time is not exhausted by physics. For humans, time is also an experience. We do not live in physical time, but in the time of perception. We have a past we remember, a future we anticipate, and a present we live. Martin Heidegger said that humans are beings toward death. Our finitude makes time meaningful. Without an end, time would have no weight. It is because we are mortal that each day has value. This brings us to meaning. If the universe is finite, does our life have meaning? Some philosophers answered no. They said, if all vanishes, then nothing matters. Others argued the opposite. Precisely because all vanishes, every moment matters. Imagine, if life were eternal, would we value it as much? Would we love, create, and strive? Meaning arises from finitude. Finitude makes life unique. Existentialist philosophers, Sartre, Camus, Heidegger, spoke of how humans themselves create meaning. The universe may be indifferent, but we fill life with significance. Camus compared humans to the mythic Sisyphus, endlessly pushing his stone up the hill, knowing it will roll back down. And yet in that effort he finds meaning, because he accepts his fate. So we too can accept the finitude of the universe and still live meaningfully. Let us pause and ask a rhetorical question. What is more important, eternity or the depth of a moment? Which is more valuable, an endless life without events, or a short life full of love and creativity? Perhaps the answer is clear. For we know that even a fleeting moment of happiness can illuminate an entire life. And so it is with the universe. Even if it is finite, that does not diminish its grandeur. It enhances it. Science, too, searches for meaning in its own way. Physicists, studying the cosmos, seek order in chaos. For them, meaning is understanding. For philosophers, meaning is acceptance. For artists, it is expression. And all these paths converge on one point. We seek ourselves in the mirror of the universe. When we ask about its end, we are really asking, what does it mean to live? The stories of scientists also reveal philosophy. Einstein once said, "The most incomprehensible thing about the universe is that it is comprehensible." Boltzmann, reflecting on entropy, saw in it not only threat, but beauty. Nietzsche challenged us. Could you live your life so as to wish to live it again and again? These words echo cosmology. If the universe will one day die, can we still say we lived well? So, my dear listeners, the philosophy of time and meaning is inseparable from cosmology. The question of the end of the universe is not only about the future, it is about our present. Time is limited, and that limitation makes it precious. In the next chapter, we will speak of the fates of stars and galaxies, of how cosmic objects live and die, reminding us of both mortality and the beauty of existence. The fate of stars and galaxies. Greetings once again, my dear listeners. In the previous chapter, we reflected on time and meaning. Now let us turn to more tangible and visible things, the fates of stars and galaxies, for they are the bricks of the cosmos. Their lives and deaths reveal to us that the universe is dynamic, and in observing them, we can better understand our own destiny. Let us begin with stars. A star is born from a cloud of gas and dust. Under the force of gravity, the cloud contracts, the temperature in the center rises, and at some point a thermonuclear reactor ignites. Hydrogen fuses into helium, and the star begins to shine. This is its youth and maturity. Our sun is at this stage. It has already burned for about 4.5 billion years, and will burn for roughly the same again. For us, that is eternity. But for the cosmos, it is but a moment. When a star exhausts its hydrogen, it begins to change. New reactions ignite in its core, the star expands, and it becomes a red giant. Light stars, like our sun, shed their outer shells, leaving behind white dwarfs that gradually cool. Massive stars live faster and die more brightly. They explode as supernovae, leaving behind neutron stars or black holes. These catastrophes forge heavy elements, gold, uranium, platinum, and we, humans, are made of the ashes of dead stars. Every atom of iron in our blood, Ev. Let us pause and wonder, is that not majestic? Every atom in our bodies was once part of a star. We are heirs of cosmic cataclysms. When we speak of the deaths of stars, we speak also of our origins. But stars do not live alone. They gather into galaxies. A galaxy is a vast city of billions or trillions of stars. Our Milky Way is but one among hundreds of billions of galaxies in the universe. Galaxies, too, are born, evolve, and die. They collide, merge, and form new structures. In a few billion years, the Milky Way will collide with the Andromeda Galaxy. It will not be a catastrophe, but a dance. Stars rarely collide directly, but their orbits will change, and from two galaxies, a new one will be born. Philosophically, the fate of stars and galaxies reminds us of our own mortality. We see that even the most majestic objects are not eternal. The sun will one day fade. The Milky Way will change beyond recognition. Yet from their deaths, something new will arise. The end of a star births planets. The death of a galaxy births new structures. Life and death in the cosmos are one and the same process. The scientists who studied stars left us inspiring stories. Cecilia Payne-Gaposchkin was the first to show that stars are made mostly of hydrogen and helium. Her discovery was initially dismissed, but later recognized. Henrietta Leavitt discovered the link between the brightness and period of variable stars, enabling measurement of cosmic distances. These breakthroughs showed us that stars are not mere dots in the sky, but living beings with destinies. And behind each discovery stood a person with perseverance. Let us pause again. When we look at the stars, we see light that traveled millions of years to reach us. We gaze into the past, and at the same time, we glimpse the future. For the fate of stars is predictable. We know they will die, and that knowledge makes their light special. It is a reminder, all is finite, and in that finitude lies beauty. What of the distant future of stars? After trillions of years, when red dwarfs have burned out, the universe will enter a new era. White dwarfs will cool into black dwarfs. Neutron stars will chill. Black holes will be the only large objects left, and even they will evaporate over inconceivable timescales. The cosmos will grow empty. Yet even this is part of its story. So, my dear listeners, the fate of stars and galaxies is a story of birth and death, of destruction and creation. It is a mirror of our own lives. We too are born, live, and die. Yet just as the death of a star gives rise to new worlds, so too does our life leave its trace. In the next chapter, we shall speak of black holes, the most mysterious objects in the universe, which also play their role in its future. Black holes and the future of the universe. Greetings once again, my dear listeners. In the previous chapter, we spoke of the lives and deaths of stars and galaxies. Now it is time to turn to the most mysterious and awe-inspiring objects in the cosmos, black holes. These entities are like gateways to the abyss. Born in cataclysms, wielding unimaginable power, they play an essential role in the destiny of the universe. Let us look at them together and try to understand what place they hold in the grand design. Black holes are born in the deaths of massive stars. When the fuel in the core is exhausted, the star can no longer support its mass. Gravity crushes it inward. For smaller stars, this ends as a white dwarf or neutron star. But for the heaviest, the collapse creates a black hole, an area of space where gravity is so strong that even light cannot escape. Hence the name, black hole. At first, the very notion seemed like fantasy. As early as the 18th century, Jean Michel and Pierre-Simon Laplace speculated about dark stars from which light could not escape. But it was Einstein's general theory of relativity that provided a firm framework. Karl Schwarzschild found the first exact solution to Einstein's equations describing such objects. For decades, they remained theoretical curiosities. But by the late 20th century, observations confirmed their reality. Today we know many candidates. Black holes come in different types. There are stellar mass black holes, only a few times heavier than the Sun. There are supermassive black holes, with millions or billions of solar masses lurking in the centers of galaxies. They govern the dance of stars, shape galactic evolution, and without them, our universe would look very different. there are also hypothetical primordial black holes, tiny ones that may have formed in the first instance after the Big Bang. If they exist, most have already evaporated. But the very idea stretches our imagination. Now let us ask, what do black holes mean for the future of the universe? Here we must recall the work of Stephen Hawking. In the 1970s, he showed that black holes are not eternal. They emit radiation due to quantum effects, now known as Hawking radiation. Very slowly, over inconceivably long times, they evaporate. Small black holes vanish quickly. Supermassive ones survive the longest, up to 10 to the 100th power years and beyond. But in the end, all disappear. This means that black holes are not the immortal keepers we picture. The distant future. Stars are long gone. White dwarfs have cooled. Neutron stars lie in darkness. The universe is quiet and empty, and in this silence, black holes remain, the last giants. But even they are not eternal. They evaporate, radiating faint quantum glow. Eventually, they vanish. The universe enters its black era, where no large objects remain, only particles and emptiness. This is a step toward heat death. Philosophically, black holes are overwhelming. They are symbols of limits. Inside the event horizon, all vanishes. Matter, light, even information. And yet they open horizons of thought. What happens beyond the event horizon? What is the singularity? These questions remain unanswered. Black holes guard their secrets fiercely. They remind us, even in an age of great discoveries, mystery endures. The stories of the scientists who worked on this theme inspire us. Stephen Hawking, despite severe illness, transformed our view of black holes. His life is proof of the human spirit's triumph over the body's limitations. His ideas on the quantum nature of horizons remain under debate. Even the disputes he had with colleagues, the information paradox, became classics of science. Let us pause and ask a rhetorical question. Are black holes not metaphors for our own perception? We see the world, but beyond the horizon lies what is hidden from us. Perhaps life itself is a journey toward horizons we cannot cross. If so, then black holes are not only physical objects, but also philosophical symbols. So, my dear listeners, black holes are not merely cosmic monsters. They are keys to understanding the future. They shape galaxies. They will be the last giants of a dying universe, and they remind us of the limits of knowledge. In the next and final chapter, we will attempt to bring together everything we have discussed. We will look at all the scenarios and ask, what does knowledge of the universe's end mean for us, and how can it inspire us to live fully today? Finale, inspiration before eternity. Greetings, my dear listeners. And so we have reached the last chapter of our great journey. Together we have traveled from ancient myths to modern cosmological theories. We have spoken of heat death, the Big Rip, the Big Crunch, the multiverse, stars and galaxies, black holes and quantum fluctuations. We have touched upon the philosophy of time and meaning, and we have looked at how the end of the world has been reflected in culture and art. And now it is time to draw our conclusions. What have we learned? First of all, we have learned that the universe is not eternal in the sense once thought. It is dynamic. It has a history. It was born, it evolves, and one day it will change again. We do not know exactly how. Perhaps it will fade in cold death. Perhaps it will be torn apart in a storm. Perhaps it will collapse and be reborn. Or perhaps the future will turn out to be more astonishing than all our scenarios. But in any case, we now know. The universe lives, and we live with it. We have also seen that the end is not always a tragedy. In myths, the end of the world meant renewal. In science, the end may be the beginning of a new cycle, or the birth of new worlds. Even in heat death, there may be room for quantum fluctuations from which something new might arise. The end is not only death, it is also possibility, and that knowledge itself can inspire us. Philosophically, reflection on the end of the universe leads us back to our own lives. For we, too, are finite. Perhaps that is why the fate of the cosmos concerns us so deeply. We see ourselves reflected in it. We fear the universe's death because we fear our own. But in contemplating it, we learn to accept finitude and to find meaning within it. We realize value arises from fragility. If life were eternal, it would not be so precious. Let us ask a rhetorical question. What shall we do with this knowledge? Should we fear it? Should we fall into despair? Or on the contrary, should we be inspired? The answer seems clear. We must be inspired, for we live in a unique time. We see the stars, we understand the laws of nature, we can dream of the future. We are the first generation to truly reflect on the destiny of the entire universe. This is not a cause for fear, but for wonder and humility. The stories of the scientists who uncovered these mysteries teach us courage. Friedman, Hubble, Rubin, Hawking, Linde, each was a person who dared to ask great questions. They did not know all the answers, but thanks to their bravery, we can speak today of the cosmos's future. Their lives show us how the human mind can look beyond horizons. But perhaps the greatest discovery is this. The universe is not indifferent to us, not in the sense that it cares, but in that it gave us the chance to exist. It gave us time, even if limited. It gave us stars from which our bodies are made. It gave us laws by which we can think and create. We are children of the universe, and our duty is to live in such a way as to be worthy of this gift. The philosopher Albert Camus wrote of Sisyphus, endlessly pushing his stone up the hill, knowing it would always roll back down. Camus said, "We must imagine Sisyphus happy, and so we must imagine ourselves happy, even knowing the universe is finite. For meaning does not lie in eternity, but in how we live our time. We can fill it with love, creativity, and the search for truth, and in that lies our strength." So, my dear listeners, here we stand before eternity. We know all will end, and yet we also know we have the present. We have the chance to live, to love, to seek, to discover. This makes us part of the great cosmic drama. We are actors on its stage, and though the play is finite, our role matters. As we conclude this journey, I leave you with an inspiring thought. The future of the universe may be many things, but that does not take away meaning from our present. It makes it more precious. We must live so that even in the cold darkness of the universe, our light will not have shone in vain. Let it be small, but let it be bright. Let it be a spark that remains in the memory of the cosmos. Thank you for walking this path with me. Thank you for your attention, your reflections, your very existence. And may our knowledge of the end of the universe not be a cause of fear, but a source of inspiration. For the end is always a beginning. And perhaps, in another world, in another universe, we shall meet again and continue this conversation.